Discovered in 2013, Proxima B has favorable characteristics which scientists believed would allow it to harbor life. But new evidence has come to light that it might be even more Earth-like than we thought, and this changed everything. The planet is located in its solar system's Goldilocks zone, which means that it is neither too far from nor too close to its host star, which creates the ideal conditions for life. It is a staggering 40 trillion kilometers or 4.25 light-years away, and orbits Proxima Centauri, the star closest to Earth. But earlier this year, NASA reported that the planet is regularly assaulted by strong radiation, making it unable to sustain water, shattering any chances of discovering extraterrestrial life there. What is this new finding that makes the exoplanet more Earth-like? How does this impact our search for a new planet to call home? Let's find out. Since its discovery was reported in August 2016, Proxima B has generated a lot of interest among astronomers and astrobiologists. An older spectrograph called HARPS, High Accuracy Radial Velocity Planet Searcher, that is mounted on a scope at ESO's SILLA Observatory in Chile, initially discovered Proxima B years ago. But with these more recent measurements, researchers now have an updated, incredibly accurate picture of the globe. The planet's small mass increase over Earth indicates that it is likely a rocky planet. The region of distances McGregor referred to as hosting liquid water is where Proxima B appears to orbit its host star. In a recent study, an international team of experts discovered that Proxima B's minimum potential mass, which is only 4.2 light-years away from Earth, is only 17% more massive than our planet. Previously, it was believed that this exoplanet, which is located in the star's habitable zone, contained a minimum of 1.3 Earth masses. The latest measurement suggests that Proxima B may resemble our planet even more than previously thought, at least in terms of size. The Echelle spectrograph for rocky exoplanet and stable spectroscopic observations, or ESPRESSO, was used by the study team to examine Proxima B. The European Southern Observatory, ESO's very large telescope in Chile, is now housing the Swiss spectrograph ESPRESSO. Spectrographs collect data about objects and separate the light emanating from them into the constituent wavelengths so that researchers can examine the object in more detail. So what is going on with this planet the size of Earth? Alejandro Suarez Mascaro, the study's principal author, described Proxima B as one of the most fascinating planets known in the solar neighborhood. Proxima Centauri, the star that orbits our solar system the closest, is home to this intriguing extraterrestrial planet. It's feasible that liquid water and possibly even life could exist on the planet, because it orbits its star exactly in the middle of the habitable zone. Proxima B could be both a rocky, terrestrial planet like Earth and have liquid water due to its mass, which is comparable to that of Earth. In a statement, however, the space agency stated that experts predict that Proxima B is subjected to torrents of X-ray and extreme ultraviolet radiation from superflares, occurring around every 2 hours. They also looked at the effects of an orbit compared to Mercury, which rotates 3 times on its axis for every 2 orbits around the Sun, a 3-2 resonance to see how the climate would behave if the planet were tidally locked, where 1 day is equal to 1 year. The scientists concluded that if Proxima B's atmosphere is like ours on Earth, then it might be able to support life. Dr. Nathan Main, the University of Exeter's scientific lead on exoplanet modeling, told Wired, "We showed the planet might definitely maintain temperatures which would allow liquid water on the surface, but that is a big if." The spectrograph for rocky exoplanets and stable spectroscopic observations, a new instrument on the ESO's Very Large Telescope, was used by astronomers to make follow-up observations of Proxima Centauri in 2020. Astronomers found the first indications of a signal corresponding to an object with a 5-day orbit, in addition to concluding that Proxima B exists. The smallest and nearest member of this 3-star system, Proxima Centauri, is where the long-sought-after planet was discovered in August 2016. Then, in January 2020, astronomers discovered a second planet in the neighborhood of Proxima Centauri. A third terrestrial planet has been discovered orbiting the star closest to Earth, and it appears that the star's family tree is now expanding once more. Red dwarf stars like Proxima Centauri are significantly smaller than the Sun. The star would appear larger from Proxima B's surface than the Sun does from Earth because Proxima B is so much closer to the star than Earth is to the Sun. According to astronomers, red dwarf planets that are in the habitable zone are most likely tidally locked, which means that they always face their parent stars in the same direction. As a result, Proxima B may have a hot side and a cool dark side. According to some scientists, it's likely that tidally locked planets' thick atmospheres disperse heat around them, making at least some regions of these worlds livable. Stellar eruptions present another problem for Proxima B and its relatives in terms of habitability. There are 3 confirmed exoplanets in the Proxima Centauri star system, with orbital periods of 5 days, Proxima D, 11 days, Proxima B, and 5 years, Proxima C. The radial velocity method, which involves closely monitoring a star to check for minute changes in location as an orbiting planet's gravity pulls on it, was used to find Proxima D. The remaining 2 planets of Proxima Centauri, Proxima B and C, were discovered using the same technique. The lightest exoplanet yet found by this method is Proxima D. However, these planets are more massive overall. This accomplishment is quite significant. It demonstrates that the discovery of a population of light planets like our own, which are anticipated to be the most numerous in our galaxy and may be capable of supporting life as we know it, is possible using the radial velocity technique. This discovery not only shows how exoplanet research has advanced greatly in recent years, additionally, it has increased astronomers' interest in Proxima Centauri. The study potential is limitless, with the discovery of 3 exoplanets in 6 years around this nearest star neighbor. The James Webb Space Telescope, which will soon begin collecting light, will be extremely helpful for these efforts. According to FARIA, a researcher at the Instituto de Astrofísica e Ciências do Espaço in Portugal and the study's principal author, the discovery indicates that our closest star neighbor appears to be full of intriguing new worlds that are accessible for further study and future exploration. The star Proxima Centauri, which is a little over 4 light-years from the Sun, is the nearest one. Proxima C is distinctive. It is a super-Earth with an orbital period of 5.2 years and a mass that is roughly 6 times that of our planet. Its orbit is therefore around 130 million miles outside the zone of habitability. Proxima D surpasses a planet recently found in the L9859 planetary system to become the lightest exoplanet ever measured using the radial velocity technique, with a mass of only 1/4 that of Earth. The method detects minute jitters in a star's velocity brought on by the gravitational pull of an orbiting planet. Proxima D's gravitational pull is so negligible that it barely moves Proxima Centauri back and forth at a rate of about 40 centimeters per second, which is 1.44 kilometers per hour. However, Proxima B revolves around a star that, despite being near our solar system, is much fainter and less massive than the Sun, with a luminous side and a dark side which are constantly faced away from the star. This is starkly different from Earth's revolving day and night pattern. According to NASA officials, the new models offer more data that may assist scientists in better understanding their many hypotheses regarding Proxima B's composition and surface conditions. According to the statement, some of those theories involve a completely dry planet, while others permit the presence of a large amount of water in its composition. Furthermore, it's not known if Proxima B has an atmosphere. The planet orbits its star once every 11 Earth days while being extremely close to it. Therefore, some scientists speculate that Proxima B's air might have been stripped away by radiation from Proxima Centauri, making it difficult for the surface of the alien planet to retain liquid water. We will be able to learn more about life on Proxima B as scientists continue to investigate this system with new and improved equipment. ESO's extremely large telescope, now being built in the Atacama Desert, will be essential to finding and researching many more planets around neighboring stars, complementing ESPRESSO's hunt for extraterrestrial life. What do you think of this new finding? Could there be hope for life on Proxima B? Comment below.